Hello, in this video I will illustrate how to solve a linear programming problem using the graphical solution procedure. This sample problem consists of 2 decision variables and 3 constraints, and I will be using a whiteboard in order to illustrate how to draw the feasible region and then the objective function, and finally find the optimum solution. So let's get started. Alright, the problem we want to solve is, as you can see on the whiteboard, is maximize x1 plus 3x2 subject to the first constraint, x1 plus x2 less than or equal to 100, 2x1 plus x2 less than or equal to 120, 2x1 minus x2 less than or equal to 40, and the non-negativity constraints. We start by plotting one line at a time and then identifying which side of that line constitutes the feasible region. In order to do that, we take one equation at a time. So in this case I'll take R1 and make that an equality, so it will be x1 plus x2 equal to 100, and we set one variable to 0, find the value of the other variable in order to find 2 points, and then connect these 2 points together. So if I let x1 equal to 0, obviously x2 is going to be equal to 100. If I let x2 equal to 0, then x1 is going to be equal to 100. So now I have 2 points, and I'm going to locate these 2 points on the x and y axis, in this case x1, x2 axis, and then connect them to form a straight line. So first point, x1 equal to 0, which is here, and x2 equal to 100, which is right here. So that's my first point right there. Let me select the drawing line. Alright, so that's my first point right there. And the second point, x2 equal to 0, which is here, and x1 equal to 100, which is right here. So these are my 2 points, and I want to connect them in order to form the line. So here we go. We take a ruler, move it over there to connect these 2 points together and draw our line. So this is going to be the line R1. And now we have to find out which side of this line satisfies x1 plus x2 less than or equal to 100. Then for convenience, I select the origin. So if I let x1 equal to 0 and x2 equal to 0, obviously 0 plus 0 is less than or equal to 100. Therefore, this side of this line constitutes the acceptable part of the feasible region. That part is not. Normally we draw a little arrow or something like that in order to signify which side is the acceptable side, something like that. Now my drawing obviously is not very good, so I leave it at that. And I am going to actually make sure I know which line I'm talking about. So this is my line R1. Alright, right here. Now, similarly, we are going to plot the second line. So we go ahead and make the R2 an equality. In this case, it's 2x1 plus x2 equal to 120. We set one variable to 0, which for convenience I let x1 equal to 0. That gives me x2 equal to 120, and then I let x2 equal to 0, which gives me x1 equal to 60. So now I identify those 2 points on the graph and connect those 2 points. So first one is x1 equal to 0, which is here, x2 equal to 120, which is right here, and the second one is x2 equal to 0, which is here, and x1 equal to 60, which is right here. Okay, so I'll take my ruler and move it over here like that and connect these 2 points. Now I have to find out which side of the line constitutes the feasible region. As before, the most convenient point would be the origin. So if I let x1 equal to 0, x2 equal to 0, and go to the second equation, inequality, is 2 times 0 plus 0 is less than or equal to 120. Therefore, this side of R2 constitutes the feasible region. First, I'm going to draw a little arrow like that to say that's my acceptable region, and I'm going to label my line as R2. This is a label for my second line. Same thing with the third line. We go. In this case, I have 2x1 minus x2 less than or equal to 40. So I let x1 equal to 0. That gives me x2 equal to minus 40. Okay. I let x2 equal to 0. That gives me x1 equal to 20. So now I will connect these 2 points. Let me just move this a little bit over here so that we are not crowding. So let's find out those 2 points and connect them together. x1 equal to 0, again it's right here. x2 minus 40, it's down here. Oops, I didn't mean to do that. So that's the first point right there. The second point is x2 equal to 0, x1 equal to 20, which is right there. And we will connect those 2 points. Like that. And I'll draw my line like so. And then we have to find out which side of this line, whether above or below, constitutes the feasible region. Again, if for convenience I take the point 0, 0, the origin, and substitute into the third inequality. 2 times 0 minus 0 is less than or equal to 40. Therefore, the above the line, the upper side of the line, constitutes the feasible region. So I'll draw a little line here. And that gives me the feasible region. Obviously, the two non-negativities, this is x1 greater than or equal to 0, and this one is x2 greater than or equal to 0. So this trapezoid shape constitutes my feasible region. Now what I have to do is to take the objective function, make it equal to a constant, draw that line, and move it as far as I can in order to increase the value of the objective function. So let's go ahead and do the same thing here. For convenience, again, I have to set the objective function to some arbitrary number in order to be able to draw the line. For convenience, I'm going to set the objective function at 60. So if I let 60 equal to x1 plus 3x2, I can draw one of the objective function lines. These are called family of objective function lines, and we will see which one would give us the largest total value. So again, we let x1 equal to 0. That gives us x2 equal to 20. Okay. And I let x2 equal to 0, that gives me x1 equal to 60, and now I'll identify those 2 points on the graph and connect them together. So here we go. First one is x1 equal to 0, x2 equal to 20, which is about there. Next one, x1 equal to 60, x2 equal to 0, which is about there. So we want to connect these 2 points. Let me take the red color so that we can see the objective function in a different color. Again, it's the point of 0 and 20 and 60 and 0, which is something like that. And now I'll draw my objective function line. Okay, we know that any point on this line, any combination of x1, x2 values on this line will give us a total value of 60, profit of 60. So we want to do is select this line and actually move it as far as we can before leaving the feasible region. So if I move this line, notice that I'm not changing the inclination or the slope of the line. I can set it here, that would be fine. I can go up here, that gives me another coordinate point solution, but that still is not leaving the feasible region. Notice this would be the one that would be the last line before I leave the feasible region, and that point is my optimal solution, which is the point of, it's the point of x1 equal to 0 and x2 equal to 100. That gives me the total objective function value. Let me call it z equal to 0 plus 3 times 100 equal to 300. And that point is my optimum solution, the point of 0 and 100, with a total objective function value of 300. And that is how we solve a linear programming problem using the graphical method. If you liked my video, please subscribe to my channel and click on the like button. Thank you.